In how many of the distinct permutation of the letters Mississippi do the four I's not come together? So what they're asking is the following. This is I's coming together. So one more example can be this. I think, yeah, right? So these are all the I's coming together. So we have to figure out, we don't want such scenario. We want everything else is what they're asking for. Okay. So maybe something like this. This is okay. Or even this is okay. We don't have all the I's together. This is okay. But this is not okay. Right, guys? So this is what they're asking for. How do you figure out this? We have to make use of complementary of stuff. What does that mean? We know that if we have to figure out P of I not come together, I can do this way. That is P total. Are you getting it where I'm going? P of I coming together. So if I subtract with the total, obviously I'll get the ones wherein I's are coming together. Does it make sense? So this is the basic funda, and on this is what we will work on. Okay. Whenever we come across the phenomena or scenario wherein we have not happening, no, this particular thing is not happening, most of the time this is the way to approach it. So let's look at how many times is it happening. Let's subtract that with the total, that from the total, and then you'll get the answer. So this is now simple set of calculation for the first half. So here, since we are handling all of it, so n is what? We have 4 and 11. We are using all of it, so r is also 11. But this is a special scenario. We have things repeating, like s is repeating 4 times, like I is repeating 4 times, and P also is repeating 2 times. So for this scenario, we have the formula n factorial divided by P1 factorial to Pk factorial. So this is 11 factorial divided by 4 factorial, 4 factorial, 2 factorial. So this is nothing but 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 factorial. This entire thing divided by 4 factorial into 4 into 3 into 2 into 2. Okay. The reason behind not doing this is so that we can cancel. Then we have 4 2s are 8, 3 2s are 6, and this I already calculated. So this is 11 into 10 into 9 into 7 into 5. So this results in 34650. Okay, and now we have P of I coming together. So in this particular setup, it will get a bit weird. So let me explain how to solve this though. First thing is, we need to consider as a group, as a set of letters, how many are there, right? And then we'll shuffle around and we'll find the answer. What I mean is this. I have the word Mississippi wherein I's are together. So there are 1, 2, 3, 6, 7, 8. There are 8 groups. Okay, I can shuffle this around and that would be your all the possible scenarios wherein I's are coming together. I'll show some of it. Of course, I can't show all of it. That's not practical. So let's have a look. So each of this, please consider that they are different words. please understand that this is a particular scenario, set of scenarios. Of course, shuffling all of this around and so on and so forth, the same thing can be repeated by shuffling all of this, right? So basically, we are in some sense shuffling around 8 groups of things. Okay, so but yeah, I'll show you how you guys will represent this, as i's are grouped together, grouped actually. We can consider, this is very important, 11 plus 11 minus 4, because there are 11 of it, 11 in total letters, 4 are i's, but I as a group will be 1. So there are so many groups. Okay, so basically this is non-i's and this is all the i's as a single group. Does it make sense? So here in total n is equal to 8. So r will also be equal to 8, is it not? And then we have to consider that p of s, there are 4 of it, and p of p, there are 2 of it. Again, this particular scenario is something that you guys have to understand. So what happened? We considered this as different set of groups wherein all the i's are a separate group. And so when we counted, there are 8 of it. Okay, so that's how we'll get this to be 8. 11 minus 4 is now all the non-i's, and all the i's as a group is 1. So there are so many groups. And now the permutation is 8 factorial divided by 4 factorial into 2 factorial. So that is nothing but 6 into 5 to 4 factorial divided by 4 factorial into 2. So this 2 gets cancelled and we can cancel this. 30 and 210 and 480, right? No, wait. 840, my bad. 840. And finally, we have all the i's not coming together. This can be answered with subtracting 34650 and 840. So this is simple subtraction. 0 1 3 8. Okay, 8 3 3. Okay, so that would be our answer. So there are 33810 possible words for the given condition. So that's your answer. So let me repeat it off. I feel like it. So whenever we talk about i's not coming together, we'll figure out all the possibilities and subtract with i's coming together. This is our whole scenario. So figuring this out is not that difficult, but this is difficult, right? So first thing is you guys need to understand this. So this is basically your sets phenomena, sets concept. This is the entire set. So this is all the possibility total, and say this is all the i's coming together. If I subtract that, I'll figure out i's where and all it's not coming together. That's what we are doing. So finding the total is not that big deal. Yes, you need to keep this in mind. Now i's coming together is again a 3-star scenario. This is where people find it difficult. You just have to consider them as group, something like this, right? So this is a possibility. Okay, and shuffling around M and all of that. So every possibility will be considered with this particular, with this particular calculation, and there are 840 of them. And subtracting those two, we'll get the answer. Okay, so now you can pause and have a look at the answer. And do write that example which I mentioned initially, so that you have a basic idea of what the question is about.